Alright, so far we've talked about potential energy and the potential energy something has based on the positions that it's at. But now let's talk about what happens when, say, you let go of a ball that you're holding 2 feet off the ground. What happens to all of that potential energy? What happens to it is it becomes kinetic energy. So kinetic energy occurs when an object is in motion. Alright, so the moment you let go of a ball that has potential energy, that energy gets converted into something called kinetic energy because it's moving. Alright, kinetic energy is dependent on the mass, but it's also dependent on the velocity or the speed that the ball is moving at. Alright, so a new equation you want to get familiar with is Ke, or kinetic energy, is equal to 1/2 times mass times velocity squared. The only thing that's squared is the velocity. Alright, the rest of it, the half and the mass, those are just plugged in as is. So, we've talked about how all energy is the ability to do work. Okay, so the work needed, say, to stop kinetic energy would be equal to the kinetic energy in the object. So there is a way to sit there and write out the work equation and turn it into kinetic energy, and that's what this slide is about. You should remember from last semester, or at least recognize, there was a distance equation that involved acceleration. Alright, so we can replace d with that. So we have mass times acceleration times, and force is replaced with ma, alright, times 1/2 at squared. Alright, and then another way of writing acceleration is vf minus vi over t. So we're replacing that a here with that. Alright, and then when you have t in the denominator times t squared, what ends up happening is this t gets canceled and the square gets canceled. So now we have ma times 1/2 times vf minus vi times t. Alright, then we're going to replace the second a the same way. Alright, so you're going to have mass times vf minus vi divided by t times 1/2, and then if we assume that our velocity initial is 0, all of these vi's disappear. Those get replaced with a 0. Alright, so you're going to have mass times 1 velocity times 1/2 times v, because again we had a t that was below the denominator multiplied by a t above, so those t's had canceled. Which, if you simplify, or at least combine your v's together, you get Ke equals 1/2 mv squared. You don't have to know this. This is just for those of you who need the proof that work and kinetic energy are equal to each other. That's how they're equal to each other. Okay? So, a sample problem for kinetic energy. So if we have a 5 kilogram object moving at 20 meters per second, what is the object's energy? So our knowns, we know mass is 5 kilograms, and we know velocity is 20 meters per second. Our new equation, Ke equals 1/2 mv squared. So that's going to be 1/2 times 5 times 20 squared, which is also the same thing as 2.5 times 400, which is 1,000. And then kinetic energy is still energy, so your units are still going to be joules. Okay? Alright, sometimes you'll have to rearrange the equation and solve for mass or solve for velocity, so let me show you how to do that. So first time, let's solve for m. What you want to do is get rid of the 1/2, so we're going to multiply both sides by 2. Okay, and that's going to make that 1/2 disappear, so we'll have 2 Ke equals mv squared. And then to get m all by itself, we need to get rid of the v squared, so we divide by that. So m equals 2 Ke divided by v squared. Alright, that one's pretty easy. You guys should be able to do that one without any issues. To solve for v, there's just kind of an extra step. Alright, so we have, if we want to solve for v, again, we're going to start by getting rid of the 2. Okay, so we'll have 2 Ke equals mv squared, and then we want to get v by itself, so first we have to get rid of the m. So we have v squared equals 2ke over m. And then the last thing you have to do, the extra step, is taking the square root so that you can have just v instead of v squared. Because the square root of something squared brings you back to just that number. So v by itself is the square root of 2ke over m. Now, the 2ke divided by m, all of that is underneath the square root. So you have to multiply ke by 2 and then divide by m before you take square roots. Okay? So, an example of how you might do this. If the kinetic energy of an object is 1,125 joules and is moving at 3 meters per second, what is the mass of the object? All right, so we're going to have our knowns, ke equals 1125 joules, and our velocity is 3 meters per second, and it's mass that we want to know. So our equation rearranged for mass is 2ke over v squared. So let's plug that in. We're going to have 2 times 1125 divided by 3 squared, which is the same thing as 2,250 divided by 9, which is equal to 250. So that's our other S's. And your units, since you're solving for mass, are going to be kilograms. All right. The problem, if you're having to solve for, say, the velocity of the object, all right, so this time our knowns, we have a 360 kilogram mass. Our Ke is 2,880 joules, and velocity is our question mark. Just taught you how to rearrange this equation for v, so you need the square root of 2ke divided by m. So if you plug that in, you're going to have the square root of 2 times 2, 880, divided by 360, which on the inside of the radical, that ends up simplifying to 16. So the square root of 16 is 4. And our units, because we are solving for velocity, hopefully you remember these, meters per second. Okay? So that's the end of kinetic energy. Please do the online assignment and then be ready for some practice in class tomorrow.